Hi, I have this contraption with a tube and a bulb here to try and explain to you what's happening in a manometer. And a manometer is something we use to measure gas pressure inside an enclosed bulb. And it works similar to a barometer, like we just learned about, but it has a closed end on one side. And again, we're measuring the pressure in here. So right now, we can see that this line is even. And what does that mean? That means that the atmospheric pressure that's coming into this open end, so all these air molecules are coming and pushing down, are pushing at the same force that the air coming from the inside of this bulb is. So the air pressure in the bulb is equal to the atmospheric pressure. Now let's see what happens if the bulb produces more force, or the pressure inside, this gas pressure in the bulb, is higher. What's going to happen if it's higher? It's going to push down this way. So here we go. I'm squeezing the bulb. It has a higher pressure than the atmospheric pressure, so it's pushing. If the atmospheric pressure has more pressure, it's going to push it towards the bulb like this. So what we have is we have a play on pressure. Right now, my atmospheric pressure is pushing much harder than the pressure in the bulb, which means the pressure in the bulb is less than atmospheric pressure. And right now, I know the atmospheric pressure is around 760 millimeters of mercury. And since it's pushing harder, the pressure of the gas inside the bulb must be less than the atmospheric pressure. And we're going to use this to run some calculations and determine the pressure that's inside that bulb. So here's a picture of my manometer, and basically you have a glass bulb filled with gas on one side and you have an open end on this side. Okay, so we use a manometer to measure the gas pressure in a bulb. So here is my first example, and notice that the liquid in here, which is usually mercury, is the same height. Okay, that means the force from the atmospheric pressure is exactly the same as the gas pressure. Now today, my pressure is 760 millimeters of mercury outside in the world. And if these are equal, that means my gas must be 760 millimeters of mercury as well. Okay? So now here's our second example. And like I said, our gas and our atmospheric pressure are going to be pushing on this column of mercury. Okay, so now they're not equal. So which one is pushing harder? Okay, it looks like the gas is pushing harder. Why? Because it's pushing down and it pushed the mercury more towards the atmospheric pressure. So we're going to say our gas pressure is greater. How much greater is it? Well, since this is a column of mercury and this is graduated, if you had a real one, the height here equals 10 millimeters of mercury. So the pressure is greater by 10 millimeters of mercury. So that means my gas pressure is going to equal my atmospheric pressure, which is 760, and since it's greater, we're going to add the 10 millimeters of mercury. Okay, so that means my pressure is going to equal 770 millimeters of mercury. Okay, and that's my gas. So why is this again? There's formulas you can use, but I think it's easier to do it intuitively. The gas is pushing down. You can see this by the rise towards the atmospheric side. That means our gas is more. So if our gas is more, we just take our atmospheric pressure and we add the height. So 760 plus 10 gives us 770 millimeters of mercury is my gas pressure. So now here's a different scenario. My column of mercury is shifted towards the gas. So why is that? Which one's stronger? Is the gas stronger or is the atmospheric pressure stronger? Well, the atmosphere is pushing harder. Okay, if the atmosphere is pushing harder, that means our gas pressure is less than atmospheric pressure. So instead of going through the formulas, I will now figure out my gas pressure equals my atmospheric pressure, and I'm going to add the height of 20 millimeters of mercury to it, or am I going to subtract? Well, we decided that our gas pressure is less than atmospheric pressure, so it's minus 20, and that is going to give me 740 millimeters of mercury, and that's what my gas pressure equals. So here are my two scenarios, and what you need to know first is what is the atmospheric pressure outside. And for this day, it's going to be 710 millimeters of mercury, which means we have a low pressure day. So I think that means rain. I'm not 100% sure. Okay, so let's look at number one. Number one, what can we say about our gas versus our atmospheric pressure? Well, we can say they're equal. So our gas pressure should equal our atmospheric pressure, which means our gas pressure equals 710 millimeters of mercury. Okay, now that's not the case in number two. In number two, this column is not equal. We have a height difference of 25. So if our gas is here and our open end is our atmospheric pressure, which one is pushing harder? Well, our gas is pushing down harder because it's moving the column that way. So our gas is greater than our atmospheric pressure. That means I'm going to take 710 plus our height difference, which is 25, and that's going to give me a gas pressure 735 millimeters of mercury. Okay, so just think, does our gas have more pressure than the atmosphere or less? If it has more, you're going to add that column. If it has less, then I would subtract that column. And of course, when they're equal, the gas pressure inside the bulb equals the atmospheric pressure outside. One last example, and this one they didn't give you the height difference, so you've got to calculate that, but they did give you the numbers. So here's 10. This is at 10 millimeters of mercury, and what I meant by graduated is here's little graduation marks on this tube. And this one is 50. So my height difference is the big number minus the little number. My height difference is 40 millimeters of mercury. Okay, and that's the height. So on your worksheet, you're going to have to calculate that. So now, what's pushing harder? Is my gas pushing harder or is my atmosphere pushing harder? My gas is pushing harder, so my gas is greater than the atmosphere. So I take my 730 atmospheric pressure plus 40, and my gas is going to equal a pressure of 770 millimeters of mercury. Okay, so when you calculate the height, just remember big number minus little number, or you could just say it's absolute value, no negatives.